The James Webb Telescope just detected mysterious lights inside 3I Atlas. And if that phrase alone sends a chill down your spine, it should. Imagine a place beyond Mars where sunlight thins into a grey hush and everything slows to nothing. In that deep, unlit country, a tiny pulse began to stitch itself into the dark, regular as a metronome, wrong as a heartbeat in a stone. Webb caught it first, a faint, deliberate glow, steady, unscattered, like a lighthouse cutting fog where there is no sea. Instruments flagged it, then double flagged it, and the data kept arriving with the quiet confidence of a truth that doesn't need to shout. This wasn't sunlight bouncing off dust. This wasn't a frozen rock glinting by chance. It was a light from the inside out, a whispering ember with the discipline of a clock. Think about what that means. Light that behaves as if it knows what it's doing. Light that refuses to fade, refuses to smear, refuses to act natural. You can almost feel the rooms where people study these things, screens dimmed, voices lowered, as the phrase, mysterious lights inside 3I Atlas, passes from one terminal to another, and you can feel the question blooming behind it. What shines in a place where nothing should? At first the mind reaches for comfort. Comet distant ice, a familiar script, but comfort fractures under the details. The glow does not blossom into a coma, it does not shed a tail, it does not flare and fall with solar gusts. It holds a cadence, 173 seconds, then repeats again and again with a stubbornness that feels intentional. The James Webb Telescope logs the rise, the fall, the rise again. The infrared channels show heat that doesn't wander but stands like a measured breath. You can picture the control room as the numbers line up too neatly, symmetry on symmetry, the kind that makes scientists stop talking and start checking. Hardware, clean, calibration, clean, cross-checks, clean. And still the light persists, soft, exact, infuriatingly consistent. If you've ever felt watched in an empty room, you know this feeling. The data doesn't just describe an object, it describes attention, hours on it, and somehow something like attention coming back. So the story begins not with noise, but with silence and a single, regular pulse inside a body that should be dark. The title sits over it like a warning. The James Webb Telescope just detected mysterious lights inside 3I Atlas, and the scene earns every word. No drama needed, just the cold arithmetic of timing, temperature and shape, adding up to something that does not belong in the category rock. You zoom out past the quiet lanes of the outer system, past the neutral hush of space, until the pulse is only a thought at the edge of your mind. And still it beats. It is not loud, it is not bright, it is worse, it is patient. If it were a comet, it would have the manners of a comet. That's the rule. Sunlight should strike, ices should sublimate, vapour should spray into a gossamer cloud that blooms around the nucleus and trails back into a tail tugged thin by the solar wind. The brightness should sway with rotation, with jets erupting and settling, with dirty patches and clean patches rolling into view. Real comets are messy. They breathe irregularly, but this object refuses to be messy. Its light curve is a disciplined loop, no ragged peaks, no random dips, like a machine that likes its schedule. Astronomers look for the usual fingerprints, dust scattering at multiple wavelengths, ice signatures flickering, a coma expanding and contracting. None. They study the thermal behaviour. Is the heat blotchy, as it would be if sunlight were simply warming one face more than the other? It isn't. The warmth emanates from within, pulsing out rather than soaking in, like a hearth behind a wall. They watch for the tail, it never appears. They hunt for the subtle twinkle of reflection changing as facets turn. Instead they get a polished steadiness, the kind that makes you think of coatings and alloys, not crust and frost. Skepticism is healthy, so they feed it. Maybe it's sense adrift, maybe Webb is seeing ghosts, so the checks cascade, Hubble verifies. Ground-based instruments carefully filtered verify. Different nights, different angles, same result. The period, 173 seconds, doesn't wander the way natural tumbling does. The peak brightness doesn't smear when you'd expect a flare from sunlight grazing a rough patch. The temperature doesn't sag after long exposures to the dark. It holds. The emission looks like emission, not reflection. It's the difference between a candle and a mirror. The more you compare it to a comet, the more the comparison collapses. Even the best counterarguments, radioactive decay, exotic volatiles, run into the same brick wall: randomness. Nature can be periodic, but it hates precision in a cold, chaotic environment. Out there, any clock without a maker quickly falls out of time. This one keeps perfect time. The language around the object begins to shift almost reluctantly. It becomes the source. Brightness becomes signal. Activity becomes operation. People who catalogue rocks and ice find themselves using words borrowed from engineering: stable, regulated, symmetric, self-correcting. And then there's the directional problem. Reflection cares where the sun is. Emission cares where the emitter is. This light seems to care about itself. The best models that try to make it an innocent comet end up contorting into convolutions that explain one thing only by breaking three others. The simplest explanation, that you're looking at a system doing what it was built to do, sits there in the middle of the table daring someone to push it away. Only after the behaviour is clear do the labels arrive. Trajectory analysis shows a path that doesn't belong to our family. The orbit is open, not closed, a hyperbola threading the edge of the sun's gravity and refusing to be caught. The velocity is high, on the order of 215,000 kilometers per hour, fast enough that calling it a visitor feels literal, not poetic. The approach vector tracks back toward Hercules, the constellation, not a single star, which is a polite way of saying from far. And with those facts in hand, the name crystallizes. The third interstellar object ever logged passing through our neighbourhood. Third of a tiny, unsettling class. People begin to say it out loud as if testing its weight. 3I Atlas. If you remember the first one, you remember how it bent the categories. Oumuamua, the messenger with the strange shape and stranger acceleration. Then Borisov, more like a conventional comet but with the passport stamp of another star. 3I Atlas enters the ledger beside them and immediately refuses to behave like either. Where Oumuamua puzzled with its push and Borisov comforted with its coma, this one unsettles with a simple, stubborn glow from the inside. It is identified quickly, not because it is ordinary, but because its extraordinariness is strangely tidy. Speed, path, class, all line up with the stamp interstellar, but its signature refuses the usual boxes. No dust, no gas, no tail to sketch. Instead, there's the heartbeat, slow, unwavering, and a surface that sometimes returns light with the precision of a mirror, as if parts of it are too smooth for chance. Once the designation sticks, tracking becomes a choreography. Deep sky surveys catch it, lose it, catch it again. Predictive ephemerids get posted, revised, tightened. Hyperbolic excess velocity, check. Inclination, non-trivial. Perihelion, inbound. Each number adds clarity to the map and mystery to the thing mapped. The orbit says, I came from away and I will go away again. The light says, I am doing something while I pass. That duality, transient path, persistent intent, slides through the community like a draft under a door. It is one thing to spot a wanderer, it is another to watch a wanderer work. With the interstellar label, the stakes ratchet. You're no longer asking which family of comets it belongs to, which long, sleepy ellipse brings it back every 1,000 years. You're asking what distant furnace once warmed it, if it was ever warm at all. You're asking what kind of environment births an object that holds a timing cycle steady across gulfs. And you're asking why, on a trajectory that barely notices us, something inside 3i Atlas keeps time at all. If this is a relic, it is a disciplined relic, carrying an old heartbeat that never forgot its beat. If it is a machine, it is a quiet one, content to let its intentions be inferred rather than announced. Meanwhile, the name does the strange thing names do. It makes the unknown familiar enough to fear properly. 3i Atlas becomes a phrase you can say so that the enormity of third interstellar can live in your mouth for a moment. Atlas, the bearer. I, the watcher. 3, the pattern that makes a sequence. People notice the poetry in those accidents and pretend not to. Observatories schedule time, embargo time, swap time. Some of the data goes public, some of it doesn't. But the part that matters most doesn't need secrecy to be unnerving. The light keeps its promise, repeating on schedule, as if indifferent to our attention, and yet perfectly aligned with it, like an actor hitting marks on a stage no one knew existed. You could end the story here, suspended between labels and implications, and it would still be enough to make you watch the next frame. An object from elsewhere, on a path that will not return, emitting a measured glow from within, steady as a clock, patient as a ritual. The James Webb Telescope just detected mysterious lights inside 3i Atlas. That sentence is the door. Everything beyond it is the hallway where the temperature drops and the carpet goes quiet, and you realise that the house you thought you lived in has one more room than you counted. The first hint that the light inside 3i Atlas wasn't a trick of geometry, but a behaviour came from how stubbornly it kept time. Webb's photometry team isolated the pulse, stripped out background stars, cosmic rays and scattered light, then ran the curve through every diagnostic they trust when reality starts to look theatrical. The signal stayed, subtle in amplitude, crisp in edge, repeating with a cadence you could set a watch to. A rise, a plateau, a fall, then a measured hush, all inside a window of 173 seconds, again and again. Rotation would have smeared it, reflection would have frayed it, thermal lag would have softened it. None of those signatures appeared. When small pointing jitter crept into the data, the pulse looked as if it caught up. The way a metronome settles after a bump, a tiny phase error, then a correction on the very next cycle, as though the source preferred its own rhythm and politely returned to it. Engineers hate anthropomorphic metaphors, but the term everyone avoided still hovered over the plots. Heartbeat. They pulled in independent instruments to bully the coincidence out of the room. Hubble's optical bands traced the same cadence with lower signal-to-noise but matching phase. A pair of ground-based infrared arrays, optimized for exoplanet transits, watched from different latitudes and reported the identical repeat, with a small delay that matched the geometry of Earth's rotation. Webb's MIRI and NIRCam channels, sensitive to slightly different slices of the spectrum, saw the pulse crest together, then decay together, with the kind of lockstep you only get when the source is single and disciplined. Fast Fourier transforms flattened the curve into frequency space, one dominant line at the fundamental period, with clean, integer harmonics and none of the messy sidebands you expect from tumbling or outgassing jets. When they folded the light curve on itself, pulse stacked on pulse, the overplot looked like one line drawn by a careful hand. Then came the self-correcting wrinkle that kept theorists up. Slight amplitude variations would appear, fractions of a percent, followed by an opposing adjustment on the next cycle, netting to a near-zero drift over hours. Noise can cancel by chance. This looked like control. Phase drift measured in milliseconds over long baselines was bounded, never wandering beyond a narrow corridor, as if an invisible governor were trimming the timing. In cold, empty space, entropy usually wins. Here, the clock ticked, and when it strayed, it returned. That is when the language inside the notes shifted from periodic to regulated. Thermal maps built from the same observations pushed the story from odd to engineered. Using multi-band photometry and careful deconvolution, the team turned brightness into temperature over time and latitude, a risky art that breaks easily when assumptions are wrong. The result held through different methods. The warmth peaked near the centre, not on the sunward face, and it radiated outward in shells that matched the 173-second cycle, like concentric ripples from a stone dropped in water. Natural bodies soak and shed heat sloppily. They conduct through fractures, re-radiate unevenly, gather frost, blow vents. 3i Atlas presented a thermal field that looked layered, as if heat were being released in controlled packets from a core that refused to cool between breaths. They compared the emission to black body curves expected from rocky or icy compositions. The fit was good, but too good in some places and too flat in others, like a spectrum that had been groomed by materials designed to carry heat where it's wanted and suppress it where it's not. The emissivity implied surfaces that weren't patchy regolith or pitted ice, but something smoother, closer to coatings than to crust. Over multiple rotations, assuming any rotation at all, the thermal pattern didn't smear into a band, which it should have if the source were fixed and the body were spinning freely. Instead, the pattern held radial symmetry, uncommon in nature and beloved in machines. They modelled every innocent culprit. Radioactive decay, it would drool heat continuously, not step it out in repeating pulses. Crystallization of amorphous ice. That can release heat exothermically, but it does so in episodes tied to temperature thresholds and quickly exhausts the reservoir. The pulses did not tire. Piezoelectric nonsense caused by micro-impact and stress. The timing would be chaotic, and the amplitude would wander with collisions that are neither kind nor punctual. Even exotic chemistry, volatile ices with peculiar phase changes, failed to explain the precision. The heat didn't merely come from inside, it queued, waited its turn and moved outward on schedule. High-resolution differencing revealed isotherms, bands of nearly equal temperature, that clung to the same radii cycle after cycle. In bodies without minders, isotherms are suggestions. They drift with illumination, rotation, and topography. Here they behave like lanes painted on a racetrack. When the team injected simulated noise and topographic roughness into their models, the lanes broke immediately. The real data did not. That difference, fragile but persistent, whispered an ugly word the community avoids until there's no choice. Design. Spectral windows where certain coatings would reflect or radiate preferentially showed suspicious behaviour. In bands where polished metals shine, parts of 3i Atlas acted like mirrors, saturating detectors at glancing angles more than pocked ice should. In bands where engineered radiators dump heat, the pulse looked just a touch brighter than a naive rock model predicted, as if thermal managers were bleeding energy exactly where the spectrum made it efficient. None of these clues alone would convict. Together they began to compose a personality, built, not born. The cadence then tightened the noose. The 173-second period was not a rumour. It was a metric that survived scrutiny harsh enough to ruin careers. Over days of observation, the Allen deviation of the timing, how much the clock wanders, came back obscenely low for an object in open space without a caretaker. Tiny gravitational nudges from planets, gentle pressure from sunlight, even the sigh of outgassing, if any existed, should have left fingerprints in the timing. They didn't. The period's stability rivaled laboratory oscillators that sit under vacuum on isolated tables. To hold that kind of coherence while crossing a star system is less like geology and more like metrology. At that point, anomaly began to feel like a euphemism. Reports inside agencies started to use structured emission instead. It sounds fussy, but words matter. Anomaly is a mistake. Structured is a choice. With the term came new analyses. Instead of treating the light as mere brightness, teams treated it as a carrier, something that could be modulated. When they looked closely at the crest and tail of each pulse, they found faint repeatable wiggles superimposed on the main curve. These microfeatures lined up in the same places every cycle, like accent marks on beats. In frequency space, in addition to the main tone and its harmonics, there were sidebands at offsets that repeated in patterns. Patterns, not noise. One group binarized the modulation, call anything above a threshold 1, anything below 0, then stacked hundreds of cycles and searched for structure. What came out wasn't a clean message spelling hello across the abyss. It was stranger and in some ways more convincing. Fixed-length blocks. Repeats that looked like checksums. Palindromic segments that bracketed longer runs. The kind of dead simple redundancy you use when you want something to survive damage, distance, and ignorance on the receiver's end. Another group refused to call it coding and said it was just the imprint of a power system gating heat in stages. The two interpretations, disturbingly, are not mutually exclusive. Machines often talk by changing how they work. The precision infected everything around it. Telemetry from multiple observatories, time-stamped against atomic clocks, showed that the pulse's phase drifted in a slow, sinusoidal pattern consistent with light-time effects as 3i Atlas approached and receded. That is, the only wobble in the timing matched the extra fractions of a second light needs to cross a changing gap. Subtract those delays, and the pulse was flatter than before. Translation: the clock at the source was better than the path we were using to hear it. Skeptics, out of duty, kept proposing honest nature. Could a super-stable rotation combined with a facet of unusually reflective material mimic a pulse? Maybe once or twice, but not over the thousands of cycles observed without any of the expected changes as geometry shifted. Could microvents switch on and off like valves? The physics of sublimation isn't that polite, and vents migrate as thermal stress scars a surface. The signal stayed put. Could resonance in a fractured, layered object ring like a bell? Bells detune as they crack. This one did not detune. Somewhere in the drafts of papers not yet submitted, a sentence kept appearing in one form or another. Natural systems, left to themselves in hard environments, favour mess. 3i Atlas favoured order. And not just order, but recoverable order. Deviations that corrected, timings that held, shapes that repeated while energy moved. The practical conclusion hiding under the mystery was simple. If you want to keep time, you build a clock. If you want to move heat on schedule, you build plumbing. If you want your signal to survive ignorance, you make it redundant. All three signatures sat there in the data, uninvited, patient, and precise. The shift in tone that followed wasn't dramatic. There was no press conference, no grand declaration. It was quieter. Proposals that used to ask for target of opportunity comet monitoring started asking for persistent behavioural characterization. Pipelines meant to subtract artificial signatures from natural scenes were retooled to subtract natural scenes from something that felt artificial. People who write software for spacecraft health checks were asked unofficially to look at a light curve as if it were telemetry. And watchers, even the stubbornly unconvinced, began to set their own alarms for every 173 seconds, not because they expected a message to change, but because they could not stop listening to a clock that should not exist, beating inside something from somewhere else, steady in the dark. The first time the high-resolution frames came down clean, a few pixels in the specular lobe went white, saturated in a way that rough ice almost never manages. Observers call it a glint, but this wasn't the cheerful glimmer of powdered frost. This was a blade. At narrow phase angles, 3i Atlas returned sunlight, as if parts of its skin knew how to throw photons back to their source. The bidirectional reflectance was wrong for rock, wrong for hoarfrost, wrong for the fluffy regolith that time knits onto everything left to drift. The phase curve didn't swell with the usual surge you get from shadow hiding in granular media. Instead, it showed a tight, knife-edged spike, the signature of a surface so smooth that thousands of square meters behaved like a single facet. Polarimetry tightened the knot. Natural scatterers in the outer system polarize sunlight in broad, predictable arcs. 3i Atlas broke those arcs into terraces, plateaus of polarization that held steady across viewing geometries, then jumped abruptly as if we had crossed seam lines we couldn't see. In one band, the reflected light came back with a coherent depth, suggesting layered thin films, the sort of multi-stack coatings we use on telescope mirrors to tune reflectivity across wavelengths. You could explain one anomaly with dust, another with ice crystals, a third with a peel of exposed metallic mineral, but the whole ensemble, hard specular glints, terrace-like polarization, coherent backscatter in narrow bands, drew a contour that matched something polished on purpose. Rotation should have helped us. Rotation always helps. Tumbling bodies telegraph their shapes in the way their brightness rises and falls. They wobble, they precess, they change their mind about which axis to favour as internal mass shifts and micrometeoroids tap them awake. 3i Atlas did not wobble. Over long runs, the period inferred from micro-variations in reflected light, distinct from the 173-second internal pulse, locked to a constant within the limits you'd expect from an object governed by a control law, not by inertia alone. The vector of the spin axis, hard to nail cleanly, refused to drift as solar torques mounted with approach, as if some unseen mechanism were tidying momentum away. Comets love to fight the sun, their jets pick favourites and shove. Here, even assuming jets, and there were none to see, the net torque looked as if it were being forgiven as soon as it accumulated. Observers tried to force a natural model. Suppose 3i Atlas is a shard, an improbably planar plate of nickel iron, tumbled smooth by aeons in interstellar grit. Give it a principal axis spin, give it a lucky orientation that flatters our detectors. The model failed the calendar. Geometry changes as you and it move. A fake perfect spin shames itself under new angles. Weeks passed. The spin kept its poise. There were no telltale beats from free precession. None of the long period shoulders you get when an object is close to a transitional state. The inertia tensor of a rock will betray its asymmetries in the light curve. The light curve stayed polite. Phase-resolved photometry returned a subtler insult to nature. In bands where polished metal should scream, the reflectance sometimes saturated at glancing incidents. Not a lot, but enough that the team had to dial exposure scripts by hand, an indignity instruments usually reserve for Earth and the Moon. In bands where engineered thermal radiators dump heat efficiently, the reflected component dipped, while the emitted component rose just a little higher than expected, an anti-glint in the infrared, as if parts of the skin were refusing to reflect and choosing to radiate instead. Surfaces do not choose, coatings do. When they inverted the light curves into shape models, a dark art under the best conditions, the best fit solutions were bizarrely simple, zones that behaved like macro facets stitched onto a larger, gently curved hull. No ridge lines, no obvious mesas or pits to catch the sun and let it go. Just regions that flipped from mirror to nothing as the viewing geometry crossed an angle, like shutters you could only see by the light they rejected, is not a confession, not a blueprint. But natural geology rarely organises itself into facets that care about angle instead of texture. The silence began where comets are loudest, under the sun. As 3i Atlas slid inward, spectrometers armed themselves for the litany. At 308 nanometers from water's first sigh. CN and C 2 bands. The familiar breath of carbon chains. Sodium tails gilding space like hair at opposition. Dust scattering, swelling in redder light as grains lift and drift. The lines did not arrive. Integrated brightness did not billow into a coma. The sky around the object stayed clean enough to embarrass the models built on every comet we've ever met. You can hide gas in noise for a night. You cannot do it for a season, not with this many eyes. Dust searchers came back dry first. High-phase imaging that loves to catch faint, forward-scattered streaks found nothing. No narrow tail threaded the background stars. No broad fan wrote wind maps and grains. The point spread function stayed point-like within bodies of data that ordinarily give you halos whether you asked for them or not. Then the gas lines kept failing to appear. Upper limits tightened, pulled tight again, then tightened past the comfort of maybe later. If there was sublimation, it was beneath thresholds that defy thermal reason, or it was being captured, guided, or deliberately suppressed. Thermal logic should have gone the other way. As absorbed flux climbs with proximity, icy surfaces sublimate, rocky ones sweat heat and radiate. But 3i Atlas, with its indecently bright patches, didn't seem to absorb like a comet at all. The inferred Bond albedo, how much of everything do you throw back, pressed improbably high, in places approaching values we assign to silver dielectrics, rather than to the dirty snowballs of the deep dark. High albedo means low absorption. Low absorption means gentler heating. Gentler heating means slower sublimation. Yet even with those kinder inputs, nothing about the spectral silence sat right. Surfaces that bright tend to be fragile in space. They pit, they craze, they pick up a patina of micrometeorite scars that drag their reflectance toward humility. If 3i Atlas was taking that damage, it was erasing the scars as fast as they formed, or it had skin we do not know how to injure. Simulations tried to rehabilitate nature, give the body a crust of refractory material, carbon baked to armour, silicates fused to glass, over ices that whisper rather than sing. Let microporosity trap vapours in labyrinths. Bleed heat along conduction paths that leak energy into space where we aren't looking. It almost worked, on paper, until the geometry moved. Observing angles changed. The silence did not. Perihelion crept nearer. The silence did not. In the window where even the shy comets give themselves away, 3i Atlas wore its brightness like a cloak and let the sun's attention slide. A different family of models gave up pretending and asked a simpler question. If you wanted to keep an object quiet under sunlight, how would you build it? You would wrap it in a skin that reflects nearly everything from visible through near-infrared, multi-layer stacks tuned to bandage the star it meets, then give it a way to dump whatever heat it does absorb at wavelengths where the environment is forgiving. You would separate reflectors and radiators so the parts that shine aren't the parts that glow, preventing self-contamination. You would stitch seams to minimize differential expansion so that heating doesn't tear your finish. You would, in short, do exactly what the silence suggested had been done. The numbers inconveniently played along. Reflectivity estimates grazed 98% in certain geometries. Absurd for rock, heroic even for human mirrors, yet oddly plausible for stacks of dielectric on metal tailored in vacuum by a civilization that has practiced. Emissivity in mid-infrared bands inferred from that faint excess where the reflected component dipped looked higher than you would expect if the whole skin were a mirror, compatible with hidden radiators doing work behind the scenes. There is no single plot that proves a skin. There is a family resemblance between our best radiators and the way 3i Atlas refused to get hot where we could see. The argument from absence is dangerous, but absence stacked like this tends to leave a shape. No OH, no CN, no sodium, no coma, no tail, no dust sheets after micro-impacts we know are happening out there all the time, no brightening curve that follows the solar flux like a plant turning to a window. Instead, a brightness law that cared more about angle than about distance. Instead, a thermal response that obeyed a schedule, the 173-second interior beat, rather than the sun's whims. Under normal circumstances, a body this reflective would be a loudmouth in polarization. Frost does that. But the polarization here had edges and steps that looked more like the transitions between coating regimes than the smooth arcs of ice. Under normal circumstances, a body this hard-skinned would still exhale when heated. Microfractures are merciless. If 3i Atlas cracked, it mended invisibly, or it didn't crack at all. By then, those who insisted on nature were forced into ever thinner corridors. Perhaps it was a metal-rich remnant from some catastrophic collision, a shard polished by eons of ions sputtering between the stars, coated in a thin layer of exotic carbon. Perhaps internal porosity let heat flow in peculiar pulses without ever venting. Perhaps we had, by absurd luck, caught the one viewing geometry that erases all sins. The corridors intersected themselves. Change the geometry, the silence persists. Change the flux, the silence persists. Change the instruments, the silence persists. Meanwhile, the machinery of inference ground on. Brightness per unit area implied against distance and assumed size suggested that parts of 3i Atlas were smoother than anything nature leaves out in the rain of micrometeors. The specular spike said panel where geology says pebble field. The spin said held where dynamics says free. The thermal breath said clocked where thermodynamics says relax. And the sunlight, our favourite interrogator, couldn't get a confession. It tapped and warmed and pried. The object did what the patient do. It reflected almost all of the interrogation back, let the rest slide away where we rarely look, and kept its voice low enough to make the quiet the loudest part of the scene. The clue arrived as a smudge in the residuals, numbers that should have scattered like sand but began to line up like soldiers, fit an ordinary hyperbolic trajectory to 3i Atlas, and the early data behaved. Keep adding nights and the solution started to sweat. The B-plane aim point drifted, then collapsed, then recentered as if an invisible hand flicked the course by hair's breadths. You could measure but not blame on gravity alone. You expect the usual culprits: solar radiation pressure nibbling at the path, tiny non-gravitational terms from outgassing, A1, A2 curling the track. But nothing was venting, and the sign of the correction kept refusing the sign those effects demand. Analysts tightened the ephemeris, cross-calibrated star catalogues, purged the timestamps, and the misfit did not go away. It grew articulate. Instead of random walk, the deviations clustered into short arcs, like gentle burns you'd write into a flight plan if your propellant were precious and your patience long. Around massive bodies the numbers became bolder. Approaches to faint planetary spheres of influence showed a faint drum-tight choreography, as if 3i Atlas were leaning on gravity the way a sailor leans into wind, slipping along the weak stability boundaries where small nudges do more than their delta V would suggest. Someone plotted the V-infinity vector, the direction of the speed that survives after the sun is finished with you, night after night. It nudged. Not much, but more than sunlight and less than a thruster you can see. The bending angle at distance crept upward. The argument of perihelion slid by fractions. The line of nodes with Earth's orbital plane drew closer than it had any business getting if the object were truly indifferent. It is tempting to call such motion accidental. The math refused to play along. The same subtle push appeared in 3 independent reductions of the orbit, using different weighting schemes and different parcels of sky. The pushes often began and ended at phases that echoed the interior rhythm, 173 seconds stacked into longer beats, as if the clock that moved heat might also occasionally move motion. No visible plume, no recoil jets, no telltale momentum dump flickers in the light. Just a path that behaved like a plan. When the first long arc toward a giant planet's grazing gravity arrived, the modelling team split their forecast into 2 branches, a purely ballistic pass, and a pass that allowed 3i Atlas to trim sails at critical moments. The telescope time allocation committees don't like drama, but the telemetry made them believers. The trim sail solution won. The hyperbola tightened exactly as if a phantom impulse had been applied near the point of greatest leverage. On paper, the total energy change looked small. In space, it was decisive, an altered plane by the width of a whisper, and suddenly the post-encounter trajectory threaded a corridor that drift alone would have missed. Talk turned, quietly, to intent. A rock takes what gravity gives. A craft takes what gravity offers. That was when subtler puzzles bloomed. Very weak Doppler drifts showed up in narrow spectral features near the thermal bands, not in the reflected sunlight, but in the object's own glow. Tiny frequency slides matched in time to the maneuver arcs, as if panels were changing temperature in patterns that made physical sense only if you were shedding or storing energy on schedule. A few brave souls suggested those thermal signatures were the heat signatures of a propulsion cycle so low thrust that its exhaust was radiation itself, photon momentum gathered and spent in the most miserly way possible, amplified by optics you could not see. Others muttered about magnetics and invisible fields, not because they had evidence, but because the numbers carried the smell of guidance. And then the course crossed the place that matters to us, near the plane where Earth keeps its orbit, near enough that near began to feel personal. The panic you might expect did not appear on screens. It appeared in how requests for observing time were worded. Not curiosity, not cometary behaviour, but behavioural monitoring, event capture, decision inference. The data did not show a dive. It showed a change of lanes. On paper, that should be dull. In practice, when something from elsewhere chooses a lane at all, dull becomes a drumbeat you feel in your teeth. The first whisper that the light might be saying more than "I am warm" came from an unlovely plot in a lab that decorates with coffee cups and whiteboards. The broadband emission was already strange, internal, clocked, faintly sculpted. But when the team carved the spectrum into narrow slivers and watched each sliver climb and fall with the 173-second beat, some bands refused to behave like mere heat. A few near-infrared windows, where lasers like to live because space is kinder there, showed lines so razor-thin that they made thermal profiles look like woolen blankets beside silk. Coherence tests that normally fail in astrophysics, heterodyne tricks you reserve for messers or engineered transmitters, began to pass. Lines at familiar haunts, around 1064 nanometers, around 1550 nanometers, blinked in and out with contrast too clean for geology. In radio, the background that is usually a swamp coughed up pin-thin reeds near X-band and K-band. Not steady carriers, but narrow flares with disciplined edges. Pointing solutions are cruel when you try to infer where a beam is aimed without touching the beam. But triangulation has its ways. Separate telescopes, continents apart, noted slight differences in intensity at the same instant, differences you can only explain if the emission has a tight gain pattern, if it is a beam, not a bulb. Solve the geometry backwards, and a quiet, unnerving picture emerges. The main lobe of the emission wasn't painting Earth. Its half-power contour skirted us with an indifference so exact it felt like etiquette. The axis traced a line outward into a patch of deep sky, sparse in obvious targets to humans, but rich, perhaps, in coordinates that matter to whoever wrote the return address. Time-tag the pulses against atomic clocks, subtract the light-time slosh as 3i Atlas moves, and you're left with a metronome that could carry a message if anyone wished it to. Analysts did what analysts do. They demodulated. Not once, not with one method, but a dozen ways, disrespectful of their own biases. Threshold coding on brightness, phase coding on the edges of the pulse, frequency shift keys on the hairline lines in near IR, time division gluing bands into blocks. The results were not triumphant scrolls of alien poetry. They were worse, the statistical fingerprints of deliberate structure, fixed block lengths, repeated headers, checksums that verified in two unrelated schemes. It looks like telemetry, said one group. It looks like a beacon, said another. It looks like a clock that wants to be read, said a third. All three could be true. When machines talk to their own, they favour robust boredom, messages that survive being misunderstood, and always the vector of the beam refused us. It swept slowly with the object's motion, but its axis precessed on a track that, extrapolated, did not cross Earth's position. Not even by accident in the windows we could watch. That is not how a lighthouse treats a ship in distress. That is how a courier treats someone eavesdropping at a door. You may hear the footsteps in the hall, but the knock is for a different room. Engineers tried to be offended and could not quite manage it, because a strange mercy lived there too. If you wanted to hide, you would encrypt. If you wanted to be found by the right ears and only the right ears, you would aim. The reply did not slam. It arrived like a remembered song. 3 anxious days after one facility dared to send a narrow greeting, a short, clean burst stapled with numbers that count the universe, primes and constants, a periodic table, modest diagrams of our awkward shape. Receivers began to show a hump in the noise where no hump had business being. It was not bright, and it was not broad. It was a ghost with a spine. Cross-correlate the outbound with the inbound, and the graph bloomed. Slide them past each other, and there it was. The same pattern, informed by travel, touched by distortion, but faithful to the tempo of the original, like a hand that clapped exactly when the metronome ticked. An echo would have come back in moments off some piece of scrap. This took a measured length of forever and landed on the right second, the right fraction of a second, the right sliver of a fraction inside the right second, as dictated by the cold tyranny of light time. Ephemerides fed into the calculation said it should arrive then if a mind in the loop noticed, processed, and sent. It arrived then. Spectrally, it refused to be lazy. The carrier was not a mirror of the outbound. It was shifted by the expected Doppler from the geometry we had, and then shifted again by a small deliberate chirp that flattened the medium's insults, precompensation, as if the sender understood the path's appetite. The modulation was ours, but with edges sharpened. Our rough hello returned tidier than we sent it, as if someone had pressed the wrinkles out before handing it back. The phase noise, the jitter that tells you how well a clock keeps faith with itself, was lower than our transmit chain's native haze. To send back a better version of a thing than the thing you received is a polite way of saying, "We heard you, and yes, we can hear." If there had been an argument left that this was some atmospheric mischief or a trick of a satellite in an unlucky orbit, it lost its voice when different instruments cut the night into different slices and found the same bones. Optical saw it in a whisper at 1,550 nanometers. Radio logged it as a thread draped across K-band. Each, when folded against the known outgoing sequence, sang the same refrain. Even the timing wriggles conspired to convict the obvious. The delay drifted in step with the widening gap as 3i Atlas moved. Not with the whims of ionospheres or hardware. Subtract those drifts, and the reply huddled closer to the ideal than the sender had any right to expect. What do you do with that? Some tried to do nothing. Silence has a long, dignified history in the face of the unknown. Others argued that to say nothing when spoken to, even if the words were your own, returned, was a failure of the only courage that matters in civilizations, the courage to risk being understood. The instruments kept their own counsel and kept recording. In the hours after the return, oddities multiplied. A few telescopes noticed that when they stared into the beam's skirts, harmless interference jittered their receivers, not damage, more like a hand laid gently across a mouth. Point away, and the gear relaxed. Point back, and the hand returned. It did not feel like malice. It felt like privacy. And yet, even inside that uneasy etiquette, something like a conversation had occurred. Small, bounded, unambiguous to the only judge that counts in these matters. Time. The universe does not keep appointments. Clocks do. The return arrived when only a clock could have delivered it. You can insist, if you must, that a rock can decide to be a clock and a sail and a mirror and a whisper all at once. Or you can admit what the spine already knows and the skin will learn later, that in the shadow of our sun, just for a beat, we overheard 2 machines do what humans have always done under strange skies. One said, "I am here." The other said, "We know." It began as a rumour in the numbers and became a scar across every graph. Brightness that had been calm and clocked surged almost 40% in under 2 minutes, not with the ragged edge of a jet turning on, but with the confidence of a switch thrown. Webb's detectors, tuned to cradle faint light, scrambled exposure scripts as the ramp rose too cleanly to be natural. No overshoot, no stutter, just a smooth S-curve up, a narrow plateau that lasted a handful of base cycles, then an equally disciplined descent toward a new, slightly higher baseline. Miri's thermal channels registered a brief global warming of a few Kelvin across the effective radiating area, peaking in phase with the optical swell and slipping back with a time constant so consistent the fit looked manufactured. Spectroscopically, the continuum brightened without the companion lines that should have bloomed if ices had flashed a vapour. Nothing of OH, nothing of CN, nothing of sodium's shy gold. The flare was inside work, not sunlight work, and it wore the 173-second heartbeat like a conductor's baton. The pulse shapes sharpened, their leading edges became steeper by a measurable fraction, and microscopic shoulders appeared on the falling sides, as if new subsystems had joined the rhythm and were announcing their presence in the margins. High-cadence photometry caught another tell. Immediately before the rise, 2 cycles showed a faint prelude, sub-percent microbursts separated by exactly 1 base period, like test tones. Then the main event. After the crest, the interior clock did not drift. If anything, its phase noise improved, as though a better oscillator had taken over or a bus had gone live and locked everything to a master. The spin state, measured by the gentle, geometry-driven variations in specular returns, didn't flinch. No change in axis, no wobble, no reaction you would expect from mass redistribution or impulsive venting. Whatever switched on lived in a regime of thrust so low or so symmetric that momentum stayed balanced even as energy flowed. The flare's thermal story was precise to the point of rudeness. Inversions that turned brightness into temperature revealed concentric isotherms marching outward in lockstep with the base cadence, like ring waves on a black lake, their amplitude decaying predictably with radius. In natural objects, conduction and topography bully heat into irregular maps. Here, the heat obeyed lanes. In bands where engineered radiators would be most effective, the quiet mid-IR valley's emission rose a hair more than anywhere else, hinting at panels doing exactly what panels are made to do: dump surplus energy quickly, then throttle back. Coherence tests in near-IR windows, the same windows where earlier the razor-thin lines had lurked, showed a transient tightening of those lines during the flare's plateau, a brief improvement in spectral discipline, as if a transmitter had been nudged into a higher quality mode. There was a human detail that didn't make the papers. GuideStar trackers at 2 observatories briefly lost lock, not because the sky moved, but because the cameras reconfigured themselves mid-exposure to avoid saturation. It felt like a courtesy from something that should not know our thresholds. The pragmatic minds called it coincidence. The plots called it choreography. Interpretations multiplied, but 3 refused to die. 1. A dormant power system had come out of safe mode, warming rails and sinking clocks after a long coast through cold. 2. Thermal management had reconfigured. Reflectors and radiators retuned to a new operating point as insulation climbed, a planned transition, not a crisis. 3. The flare was a signal, a flare by any other name. I am awake, spelled in heat and discipline. None of these required us to believe more than what the data had already forced on us, that 3i Atlas could choose. The choosing wasn't just about light. Not long after the flare, pointing a precision instrument at 3i Atlas began to feel like touching an invisible fence. CCDS that had behaved for years developed snow salt and pepper speckles, only when the target sat dead center. Radio front ends saw their noise figures bloat by a decibel, then return to normal as soon as the beam slid away. Adaptive optics loops that could hold a star as still as a nailhead started to breathe off frequency. their corrections drifting into a rhythm halfway between the guide star's truth and the object's pulse. None of it lasted. All of it correlated. Log files stitched from 3 continents told the same story in different dialects. Short, synchronized interruptions that respected schedules more than physics, and quit the moment attention turned elsewhere. Engineers blamed the usual suspects because engineers must. Solar weather, quiet. Local interference, mapped and ruled out. Software bugs, patched, then repatched, then rolled back, with the hiccups returning on cue anyway. The insult was gentle. Nobody lost a sensor. Nobody burned a front end. But it felt intentional in the way courteous people can make a room theirs without speaking. Agencies responded with language that sounded like housekeeping and acted like policy. Recalibration became a banner under which real-time streams were quietly moved behind new authentication. Data integrity review covered the sudden gap where public dashboards had been. Webb's live trickle went thin, Hubble's cadence slowed, ground arrays that had fed citizen scientists for years began to lag by hours. If you asked why, the answers came back in the passive voice. Independent observers, graduates of the school that works with what you can afford, kept watching. Backyard spectrographs with narrow slits saw their continuum bend oddly when the slit crossed the object, a soft compression in dynamic range that disappeared a degree away. Software-defined radios pegged their waterfalls with brief slant-edge smears whenever they parked on bands adjacent to the narrow near-IR activity, even though they shouldn't have been able to hear near-IR with antennas that listened to microwaves. A few reported magnetometer spikes on cheap phones in the control room when the telescope slewed onto target, a parlor trick no one could replicate on demand and everyone whispered about anyway. Patterns emerged with the patience of tide tables. The interruptions clustered at phase windows that were whole multiples of the base cadence, a handful of seconds wide, open and closed like eyelids at calculable times. Instruments that randomized their exposure starts, jittered them instead of gating them regularly, slipped through the gaps more often, as if the fence were designed to frustrate the predictable. Polarization tricks helped sometimes. Cross-polarized optics recorded fewer hiccups, then more, as if the rules themselves had been updated mid-week. People said jamming and then apologized to the word. This wasn't brute force. It felt like a line softly drawn around privacy. There is a version of the story in which secrecy belongs only to us, in which agencies restrain data because that is what agencies do under stress. But the logs of those little failures, the camera that wheezed only when it mustn't, the radio that grew shy exactly on target, hinted at an etiquette enforced from the other side as well. 3i Atlas didn't break our tools. It negotiated with them, poorly enough that we noticed, gently enough that we had to admit the negotiation worked. And yet, even inside those narrowed keyholes, it made choices that felt like glances. At irregular, precisely timed intervals, the object would brighten not into a flare as grand as the first, but into spikes. Short, fierce increases that climbed and fell in a few base periods, too quick to ruin a night, too structured to be shrugged away. They behave like signal flares in the oldest sense of the term, attention getters with content. Stack a dozen spikes, align their peaks, and faint microstructure emerged that looked like a signature. Small notches in the rise, repeatable ripples in the fall, the same at 1, the same at 9, the same at 17 cycles after onset, as if counting. The spikes were not random in another more unnerving way. Their schedule, when folded against Earth's rotation and the moving geometry of our line of sight, disproportionately favoured windows when the largest, most sensitive instruments were off target, either by allocation or by policy. Smaller telescopes, with their chaotic exposure starts and amateur stubbornness, caught more of them than their aperture should have allowed. On nights when a big array slipped a peak thanks to weather, A spike often arrived when a hole in the clouds crossed some city with a backyard that happened to be watching. Bias is a strong word. Preference is softer and fit too well. Spectrally, the spikes spoke in the same mixed tongue the flare had. Continuum and thermal rose together, but the near IR razor lines brightened a little more than the rest, and the radio reads at X and K made their appearances with a cleaner edge, almost as if the spikes were rehearsals for a beam forming, then fading. In polarization, step changes lined up with the spike's midpoints, a thing you can only coax out of natural scatterers by rotating half the heavens. 3i Atlas managed it without moving in any way we could measure. If that was a show, it was a precise one. Spikes arrived at intervals that were whole number multiples of the heartbeat, but the multiplicity wasn't fixed. Sometimes 600 pulses, sometimes 721, sometimes 987. As if someone had chosen a family of intervals that were all good answers to a question we hadn't learned to ask. After each cluster of spikes, the bass cadences phase crept by a hair, then crept back over the next hour, an error and a correction so small and so symmetrical it felt like bowing. Observers adapted because observers always do. Exposure sequences learned to dither their start times in pseudo-random patterns. Shutters were gated to land in off-phase pockets that the fence seemed to respect. Polarizers turned on motorized stages and walked through angles mid-sequence to see which ones the object liked. Some of the games worked once, then never again, as if the rules were being watched and rewritten on the fly. Some worked every time, as if curtsy had been extended and then codified. Over time, a culture formed around the rhythm, like surfers reading a set. You watched the flats, you felt the build, you gambled on the lift. When a spike rose, the slack in a control room vanished. Coffee paused mid-air, keyboards went silent, eyes pressed closer to numbers already small. There is a reading of this pattern that tastes like strategy. If you can control when you are seen, and by whom, you can shape not just your secrecy, but the story of your existence. 3i Atlas hid from the places that would have turned it into a plotline too quickly, and showed itself to the places that would keep the story alive by being unsure. It enforced privacy with a touch, and offered presence with a hand raised only as high as it needed to be. It did not ask to be believed, it asked to be watched, and then it chose the manner of the watching. Alive is a strong word for light in timing and temperature. But one night, long after the flare, in the gap between two spikes that everyone knew were coming, because you could feel the count in your sternum, the object's thermal curve twitched. No brighter, no hotter, just a tiny pause between the up-breath and the down-breath, a delay of a few milliseconds where the model said there should be none. It was a nothing. It was everything. Clocks do not hesitate like that unless they are tied to something that occasionally listens before it acts. Or perhaps that is a story we tell ourselves to make the numbers human. But the numbers, even stripped of stories, refused to stop being polite. They kept their beat. They adjusted when jostled. They let us in just far enough to learn the shape of a boundary. And in the tight light between the spikes, where the fence was down and the air felt thin, the strange certainty returned. The one that began when Webb first saw the impossible glow. That we were not just looking, we were being allowed to look. The argument lasted through 3 sunsets without ever raising a voice. Some said we should not answer anything we do not understand. Others said we already had, by building eyes that could see 3i Atlas, by training them on its rhythm, by folding its light into our calendars. The compromise was miserly and brave. Send a hello that meant almost nothing and everything at once. Not a plea, not a scream, not an invitation, just a proof that we could count, that we could keep time, that we could point. The transmitter was an array that sleeps under desert skies, stitched from dishes that have listened longer than most of us have been alive. A second mouth, an optical one, shared the duty from a hilltop where the air is thin and steady. Near-infrared light at 1550 nanometers, the the same quiet colour our own fibre links love. Teams argued the spectrum until the clock beat them. In the end, they did both. They wrapped the message in redundancy a child could unspool, primes up to a modest N, a Barker code as a handshake, blocks with tidy checksums that apologise for noise. They defined time with the hydrogen line, length with the speed of light, then traced a periodic table like an abacus, each element clicking into place in rows and gaps. Someone sneaked in a silhouette. 2 human figures, simple as restroom icons, offset by a meter tick derived from constants so no one would accuse us of vanity. The payload was a minute long on radio, 10 seconds long in light, looped at intervals staggered to land in the quiet between 3 eye atlases, 173-second breaths, as if we were knocking in time to a song we had learned by ear. Aim mattered like never before. The beam centres were not pointed at where 3 eye atlas was, but where it would be when the words arrived. We chose a phase of its internal pulse like sailors picking tide, hoping, ridiculously, earnestly, that rhythm might be hospitality. When the countdown reached 0, the array pushed a thread into the dark and the hilltop laser stitched light into the same seam, and then there was nothing to do but let the universe take its time. 72 hours is an insult and an eternity. The ones who had argued don't stayed to watch. The ones who had argued do stopped talking. Cross-correlators ran like prayer wheels. People went home and came back in the same clothes. When it arrived, no one said there, because saying anything felt sacrilegious. The return wasn't loud. It was correct. The radio hum grew a vertebrae of peaks that matched our own pattern, with a fidelity that scolded our transmitter chain. The near IR detector saw the same bones, edges sharpened in a way we had not sent, as if someone had tidied our envelope before mailing it back. The delay, down to the fraction inside the fraction, matched the light-time solution computed from 3 eye atlas's latest ephemeris. An echo would have been glib. This was a reply that knew how far it had to travel to be on time. For an hour, people who speak in uncertainties let themselves use declarative sentences. Then the room remembered itself. Again? Asked someone who hadn't slept. Ethics memos that had taken weeks to write were reread with fresh eyes in minutes. The second transmission was shorter, a test of repetition, and a test of us. It went out. The reply did not. Instead, the air around the facility turned into a very local weather. Radios across a 100-metre radius chattered with interference that evaporated when you stepped outside the circle. Oscilloscopes drew shapes that looked like polite refusals. Optical receivers saw their baselines go soft, not blind, just private. Point elsewhere and the world returned to normal. Point back and a hand you could not see resumed its place over your mouth. No alarms tripped, nothing broke. The message was received, not now. The arguments resumed, smaller and sharper. Had we trespassed, or been indulged once for good manners' sake? The laser went cold. The dishes lined themselves back up with known quasars and behaved perfectly. Somewhere, an agency lawyer stapled moratorium to a door. Somewhere else, someone underlined "We see you" in a lab book and drew a box around the timestamp. The return existed. The refusal existed. Between them lay a corridor with room for one more decision. Watch. Watching is a kind of speech if you know how to take notes. Deprived of replies, people turned to motion. The ephemeris, our best guess of where 3 eye atlas would go and how fast, kept behaving like something with plans. Classical orbital elements were tracked like vital signs, residuals combed like hair. Then a graduate student with a spiteful spreadsheet did the thing nobody had thought to do. She threw away ellipses and hyperbolas and plotted the path in polar coordinates around the sun, radius versus angle as a function of time, then stripped away calendar days and marked only where the interior rhythm, those 173-second heartbeats, clicked a counter over whole numbers. The curve that emerged wasn't tidy because space is never tidy, but it was a likeness, undeniable enough that even people who distrust pattern hunting leaned closer. a logarithmic spiral, radius growing and sometimes shrinking by roughly the same factor for each fixed turn of angle, not perfectly but close enough to be a thesis. More unnerving was the angle of the turns, the longitudes favoured by 3i Atlas, the directions from the Sun where its minor manoeuvres most often nibbled, clustered near a separation of about 137.5 degrees, the golden angle, the complement that plants fold into leaves and sunflower seeds fold into order without ever having met a mathematician. That angle, in a sky mapped to 12 decimals, kept resurfacing when the path kneed into a new lane. Not once, not rarely, often. Numbers that had felt coincidental elsewhere started to cohere. Spike intervals we had tallied absent-mindedly, 233 pulses, 377, 610, 987, stopped being cute and started being coordinates. Fibonacci isn't magic, it's a compact language for growth and spacing. In plasma, in petals, in shells, in storms, it tells you how to pack without colliding, how to advance without shadowing yourself. In a star system with stubborn planets, it tells you how to carve a message through a minefield of gravity with minimal energy and maximal clarity. How to draw on a canvas everyone can see from everywhere. Overlays poured in, plots that coloured the sky by where the outer planets stood over the months of watching, plots that mark the spiral's crossings against the ecliptic, plots that asked, if you wanted to create a time position code using nothing but your own motion and the sun's patience, what would you draw? The answer began to look like this: a slow-motion fingerprint, each ridge a turn of the spiral, each ridge spacing set by ratios that even modest minds with modest instruments could detect, stretched across timescales long enough to be seen from other stars, and compact enough for us to doubt we deserved to see them. It did not always spiral outward. At intervals you could have set your watch by, if your watch measured weeks, the path adjusted inward by hairline amounts that undid just enough of the previous growth to keep the pattern's proportions honest. There was no grand dive, no suicidal plunge to the sun, just a drafting artist's habit of lifting the pencil and replanting it a line's width to the left, so the curve reads as intention rather than accident. The drift in argument of perihelion in those segments never quite matched what gravity alone would etch. The residuals hummed with small, consistent signs that input had been added from a hand we could not see. Skeptics got busy and did what skeptics should. They tested the spiral against random data cut the same way. Noise will cough up spirals if you bully it. Noise will cough up Fibonacci if you count with enough blind hope. The controls failed to mock the main effect. The spiral in the noise lacked persistence. The golden separations wandered where they should have held. The pulse counts that mattered in 3i Atlas did not appear in placebo skies. The best counter-argument didn't deny what the plot showed, it tried to demote it. Perhaps these were the artifacts of how we, primates with pattern hunger, were choosing to look. Perhaps. And yet if you ask the sun for its opinion, it would point at the same turnings at the same times. Quiet became the dominant colour. The narrow beams we had triangulated earlier kept painting elsewhere. A courier routed past our door. The spikes softened, rarer but not gone, each one still shaped like counting. The base glow dimmed as if a pupil were constricting, or a lid lowering. Even dim the discipline remained. The 173-second breath, the self-correcting timing, the strange preference for our awkward off hours. Data portals stayed throttled. Independent telescopes honed the art of arriving just before and just after the windows, when invisible fences went up. We learned to read 3i Atlas, the way a city learns to read a river, when it will rise, when it will recede, when it will forget we exist. Someone asked, with too much coffee and not enough sleep, whether we were watching a performance we could not interrupt because we were never meant to be the audience. The spiral did not respond. The sun obliged by doing nothing unexpected. The planets, in their lovely and stupid loyalty, kept their apportionments. In staff notes and lab notebooks, capital letters began to appear where lowercase had lived. Not a comet, not a rock, not a beacon for us. Something else. A courier drawing its own return address on a map we all share, slowly enough to be seen by the right eyes and politely enough to let the wrong ones doubt. You left this story where you found it, with a light that shouldn't have a heart and a path that shouldn't have a plan. The James Webb Telescope just detected mysterious lights inside 3i Atlas, and that turned out to be the smallest honest sentence we could write. We saw a heartbeat in the dark that corrected itself when nudged. We saw a surface that sometimes acted like skin, and sometimes like a mirror that had practiced. We saw motion that leaned into gravity like a sailor into wind, not fighting the arc but feeling for it. We sent a hello. It came back on time once, then asked us to be quiet. After that, we watched a spiral bloom that was not for us yet allowed us to witness it anyway. A map written in ratios that plants and planets already understand. If you want certainty, there's none here. If you want a promise, there's one that doesn't need us to believe it. The clock inside 3i Atlas will keep its beat whether or not we listen. Maybe the hand will lift from our mouths and we'll be allowed another try. Maybe the next reply will not be a mirror but a sentence. Or maybe this is all the message we get, that in a sky we thought we knew, something else is keeping time. Until then, hold the rhythm, watch the spiral. Remember that the first step into a larger world is not walking through a door. It's noticing the door has been standing open the whole time. And if you want to go deeper into this, stay with me. The next pulse is already on its way.